So chapter 11 is the standard template library algorithms, STL algorithms. So all algorithms are methods inside C++. When you hear algorithms, you think about this sophisticated sort of machine or something like that. But all algorithms are, when we're talking about the standard template library, the algorithms associated with that are methods and functions that are available for us that C++ gives to us. And chapter 11 is a collection of algorithms that allow us to deal with containers. So things like vectors, lists, maps, strings. Allows us to do things like counting, sorting. We can loop through. There's for each functions. There's a search. We've got a section on search functions, modifying algorithms. So like things like replace, fill, copy, remove. These are things we've talked about, especially around vectors in the past, but it's that similar, all those similar type of operations where you need to either search, loop through, move, reorder, all of those things around containers in C++. So we're just going to look at a couple of slides here, and then we'll look at our we'll look at our coding assignment that we're going to do. So I'm going to share my screen here. So I'm just going to cover a couple of functions, a couple of algorithms in C++, see how those work. And then the reason I'm covering these specifically are these are the ones we're going to look at inside the coding assignment we're going to do. So min-max operations, really straightforward. You just got a min element, and max element is the function name, and then you're adding this starting element or the beginning element, and then the ending element is what you're passing in as parameters. So you see an example here. We've got a vector called nums. You've got a handful of numbers that are in there, and then we're creating a variable called min iter here, and then we're calling the min element function, and then we're passing in the beginning and the ending elements, and then the output here is going to say, min is 34. And of course, if we look at the numbers we see up in the vector here, that 34 is going to be the minimum number. Max element again works the same way. Again, it's just going to look for the max number rather than the min. The other thing I wanted to look at is how to deal with maps. So the word counter program, which is exercise 11.2 in the book, that's one of the exercises I'm going to ask you to make modifications to. So that's why I wanted to cover this, just to sort of give you a sense of what some of the underlying code does. So in this case, let's say we've got a map. And so if you recall, a map is this sort of key, what I like to call key value pairs. So in this case, we've got a map of products is what they're calling, but they all look like musical instruments to me. So, guitar, piano, drums, violin. Then you've got a price assigned to each one of those. So we've got a display function here that's been created. We're simply passing in that pair as an argument to the display function, and then the cout statement is going to call this dot first. Notice we've got this dot first and dot second methods that we're calling, and first and second correspond to. So in this first elements case, or the first key value pairs case, p dot first is going to be guitar, p dot second is going to be 199.99, and you can see an example here where you can use a for each loop to the arguments that we're passing in here are the beginning element, the ending element, and then we're passing this display function in also. And so of course that's going to output each of the key value pairs for us. And then they've got some examples here of using sum and accumulate too, and again, you can read more about those in the book. And then finally, counting pairs. They've got an example here of counting pairs that meet a certain criteria, and this is going to be key. Again, we're going to use this inside the assignment there that we did. So this is really straightforward. They've just got this countif method that's being passed in, and then that gives the output of num underscore low is 3. Okay, So with that being said, let's look at the example we're going to use in the book. So let me go ahead and share my desktop here. Okay. So this is our Chapter 11 assignment. So again, what I'm asking you to do here is, in the second assignment, is complete exercise 11.2 in the book. And then in addition to the book requirements, I'm asking you to also do two other things here. So the one we're going to look at is use the min-max algorithms. That's referenced on page 412 to find the words that occur most often and least often. Now, there's a little bit of a trick here because you can't, well, shouldn't say you can't do it, but the fact that I'm asking you to use the min-max algorithms, those can only be called on vectors. So we've got to take the map information from the word counter program and then get that information, or get at least some of the information, into a vector, and then that's what we can call, well, that's what we can call the min-max functions on. So let's look at how to do that. So first thing we're going to do, all right, so this is the word counter program, and I haven't yet added this functionality yet. So this is sort of, I've implemented all of the requirements that the book asks you to implement. And so when I run those, notice we get word counter program. I think Dickens.text is the text that we're displaying here. So it counts 60 words. It shows us the unique words. And then this count, count per word area is where we're actually looking at the key value pairs. This is the map that's being displayed. And let me go up here. So this is the map that's being displayed in the word count, this is the key value pairs that are being displayed in the word count map. And you can see, let's see where we're doing that at. We're calling the display. Let me search for display. Yeah, so in this for each here, this is what's actually displaying these key value pairs here. We're calling the word count dot begin, word count dot end. So that's the range that we're passing to this for each loop. And then we're calling this display function. And then if we look at the display function down here, again, this is similar to what we looked at in the slide, where we're passing this pair. We're passing the pair as an argument to the display method. And then this p dot first is going to correspond to like the words, in this case, age, belief, best, etc. And then p dot second is the actual count, for each one of those. Okay, so again, I asked for the minimum and the max of the number of words. So essentially what we need to do is, what I'm going to do, the way I'm going to approach this is we're going to create a vector. We're going to add each of these word counts, so just the numbers to that vector, and then we're going to sort that. We're going to look for a match, and that's going to tell us the words that have the max count. Okay, so so let's do this. So I've already done. I've obviously already sort of solved this off camera. I'm not coding this on the fly. But first thing I'm going to do is create. I'm going to create a min-max. I'm going to create a function called min-max, and then we're going to be passing the word count map to it. So first thing we're going to do is declare the function at the top. So I'm going to do void min underscore max, and then open close parens, and then we're going to pass pass our word count. We're going to pass our word count map to that. And then we're going to do word count here. Okay. And so I'm going to save this and just see. So yeah, I've got a missing, okay, I've got a missing tick mark here somewhere. So I think this is the issue here. Okay. All righty. So I've declared this min-max function here. So now we're going to scroll down to the bottom, and we're going to actually create this function here. Now, rather than me typing all this in, I'm just going to paste this function in, this particular function in. So let's copy that, and I'm going to put it here. All right. Okay, so let's look at what we're doing here. So again, this is just, I'm defining the min-max function that I declared at the top of the program. We're passing this word count map, this set of key value pairs, same key value pairs we see here. We're passing that to the min-max function. Now, again, in the requirements, I ask you to use the max element method to find the word that has the greatest number of occurrences. So if we look down here, there's actually a number of them, but it looks like 10 is going to be the greatest. So like it, you see it occurs 10 times, of occurs 10 times, the occurs 10 times. So there's a number of them, but 10 is the max. So we're going to find one or more of those. So what we're going to do inside this function, we're creating a vector here. We're creating a vector called nums, and then we're going to loop through our word count map. And notice we're doing p dot second. We're adding the values from the value part of the map. So that second value, which is the number of occurrences, we're just adding that to our nums vector. Okay. At that point, now we can use this max element method, and we're just going to pass in the beginning element and the ending element, and that's going to find the highest number inside that vector. Now the key is there, once we find the highest number, if we just display the result of that, we've got a number, we don't know what word is associated with it. So that's why we're actually doing this if statement here. So notice now we actually loop through word count, and then we do if pair dot, or actually I'm sorry, we're going to loop through the map, and if pair dot second is equal to our max words variable that we found up here, then we're going to output the word, in this case pair dot first. Okay, so that's the method. Now let's actually call it. Now back inside our main method, we need to actually call that. So we can output it down at the bottom here, maybe. Let's see. So let's do min underscore max, and then we're going to pass our word count map to that method. And let's see. Let's just run that and see what our output is. Okay, so yeah, so here we get the output we get is words that occur 10 times are it, that the words are it, of, the, and was. Okay. So, and yeah, that's, in fact, you see the cout statement inside our method here. The words that occurred, the words occur, and then max words times, and then we're actually looping through, and that's where we actually display each of the words here. Okay. There's a few different ways to do, or there may be other ways to do that. In fact, I'm sure there are different ways to do it. So I'll leave it up to you all how you'd like to do it. But this is a way. So you're going to use a similar method here to find the minimum number of words too, and you should be able to do it. I mean, I sort of purposely named this min max. So really, you should be able to call, similar to what I did here with max words, you can create one called min words, and then pass in again the beginning and the ending elements, and you should be able to get the minimum number of words then. Okay, I will stop there. I won't say anything else about that assignment. Let's go ahead and look at Moodle again. And then I'm also asking you to prompt the user for a word, then search the words, and then search the words and see if you can find that word, and or yeah, find the word and the number of times it exists, or if the word doesn't exist, then you can just simply print out a message that said the word does not exist. And I put a link to a Stack Overflow, a Stack Overflow post there that could be helpful there. So I'll stop there. Again, if you have questions throughout the week, please let me know. And good luck and stay safe. Thanks. Bye-bye.